Hi, my name is Akinori Kimura, and today I'm going to be working on problem 16 from section 4.4 of week 5. And the problem reads, suppose an airline policy states that all baggage must be box-shaped with a sum of length, width, and height not exceeding 108 inches. What are the dimensions and volume of a square-based box with the greatest volume under these conditions? And to keep the video under 5 minutes, I've already written out my solution. And so I let x be the length and the width of the box. And we can assign the same variable for the length and width since we are talking about a square-based box. And I let y be the height of the box and v be the volume of the box. And so we can draw out two equations from this, the volume equation, which is v equals x squared times y, which is essentially base times height, and the restriction, which states that the sum of length, width, and height must be less than or equal to 108 inches. And I went ahead and used the equal sign instead of the less than equal sign, because it's fair to assume that if we want to maximize the volume, we want to use as much length, width, and height as possible. And so here, I wanted to eliminate the y to make my derivation step easier. And so I solved for y over here. So we added the x's to get 2x, subtract the x, 2x, and we get y equals 108 minus 2x. And we plug that in over here, and I distributed out the x squared again to make my derivation easier, and we end up with this being our volume equation. And I took the derivative of both sides with respect to x, so we get dv dx equals 216x minus 6x squared. And now I want to find the critical point to find the maximum, so I set dv dx equal to 0, and so we get x equals 216x minus 6x squared. And I factored out the x, so for the x, for the critical points we get 0, and we set that equal to 0, and we end up with x equals 36. And so our two critical points is 0 and 36. And so we draw a line over here, and we want to pick a value of x between 0 and 36, and one that's greater than 36. So for this interval, I chose x equals 1 because it seemed the easiest. And so we plug in 1 for x. We get 1 times 216 minus 6 times 1. And over here we get 210 multiplied by 1, which gives us a positive value. So in this interval we will have a positive value of dv dx. And for dv dx, for this interval, which I chose x equals 40, and we plug it in, 40 times 216 minus 6 times 40, and we get 240 over here, and 216 minus 240 gives us a negative value, and 40 is positive. So when we multiply these out, we get a negative value. And so it indeed becomes a maximum. So we get a maximum at a critical point of x equals 36. And now we found the x, which is the length and width of the box, and now we want to find the height of the box. And so we get our original equation, or restriction equation, and we add the 36, and we get 72, subtract 72 on both sides, and we get the height being equal to 36 inches, just like the width and the length. And now we want to find the volume, and so the volume is equal to 36 times 36, which is the base, and the height we just found, which is 36. And when we multiply that out, and when I punched it on the calculator, we got 46,656 inches cubed. And so that's the volume, and the dimension, height being 36 inches, length and width as well. And that's it. Thank you.